I'd like to sit here and tell you that everything is peachy keen, but that would be a lie. We have today a Milwaukee oscillating tool, catalog number 2836-20, 18 volt, piece of crap. I think these things are about 200, I mean just the tool alone, without the battery. I think they're about 200. I'll put the price down here on the marquee in the bottom here when I figure that out. But one of my guys came to me, different guy than the one I did the drill on. We bought the drill and this at the exact same time. So, and this one had a little bit more use on it than the drill. And listen to this. Oh yeah, this little thing goes in and out. This right here does absolutely nothing. It's almost like there's a shear pin in here that drives some kind of a piston grabber, kind of like on the top of one of those old milling machines. But something broke in there, and when you run it, that happens. Sounds like something is not meshing properly. So today we're going to figure out what's going on with it, or at least try to anyway. What's going on with it. And once again, Milwaukee, I mean, there's guys out there like myself that rely on these tools. That when one of these tools breaks, the job's done. It's done. You're not getting that job done for today, because now you've got to go back and you've got to replace this. And if this tool is $250, well, man, that's an hour and a half worth of work right there that the customer is not going to eat that cost. That means you, the guy with short fingernails, you're going to eat that damn cost. So let's tear in this thing and find out what's wrong with it. If this ever happens to you, you're using a tool and you have a little tiny screw, really small screw that your thumb just can't grasp, and you don't have any fingernails because you trim them all off, because after all, I'm not winning a beauty contest anytime soon, and grease is much easier to clean underneath fingernails when you don't have fingernails. So you use your tool, right? Your metal tool, your iron ferrite tool, to try to pick up the screw, but yet it doesn't have any magnetic properties. You need one of these little guys. Just run it through there a few times. I don't know if there's a maximum or a minimum. I just do it several times over, and then, as the French say, if I can make sure it's unscrewed, voila. And if you have something that is magnetized, like this tool here, and you don't want it magnetized, just run it right back through the same tool, just on the other side. Again, I don't know how many times you have to do it. I just do it until, then you go to pick it up, and it won't pick it up. Handy little thing to have in your toolbox. It works for any kind of steel tool. Alright, so now we got it open. I don't see anything. I was wrong about that little detent. I thought it would be directly connected, but it looks to be more like a pocket knife. That this piece here is supposed to impact that and press, but there's some kind of a keeper, because I have one of these on my truck. My buddy, this is my buddy's from his truck, and when I press this lever forward, it actually does not push that down. So this stays up somehow, and it, I don't know, unlocks, engages, does something. It's hard to describe because I really don't know what's going on. This is my first time taking one of these things apart. So I don't think it's the lever itself, but I don't think this piece here is supposed to move. So that's probably going to give us our answer once we figure out why is it moving now and it shouldn't be moving. Alright, so I got power connected. I ran it for a second. I didn't see anything. Let me see if I can angle you down this way so you can see what's going on here. So the oscillation back and forth on the blade happens because of this cylindrical motor, and You're probably not gonna be able to see it because it's just gonna be a blur, but it's slightly offset from center. That there it works around kind of like a rotary engine on like an RX-8, RX-7. I can flip this stupid switch. See how it's not centered, which is good. That's what you want. So good news is it's not a motor issue. It's obviously not a power issue. It's something on the drive head. And again, I don't know, I don't see any parts in there that are broken off. What does concern me is that on mine at work, it has 0 hours on it. I've never even used it once. This lever is really freaking tight. I mean, because it snaps down like that, right? And then when you go to deload this drawbar, like from here all the way over, there's pressure. And on this one, I know I have crap lighting. I'm using a diopter magnifying light as my stand for my phone, and then my phone as a camera, and it's not the best thing in the world to use. But you see in there, that pin that's connected to this shaft is not even touching this cam. Like I said, on mine, as soon as you unclip it from right there all the way over, just like a lockable folding pocket knife, see how the lever pushes it down there? I have a little bit of tension back this way just to push it up. So as I rotate that forward, it unlocks it. Now mine works. I sadly don't have mine here to compare side by side. I should probably do that, but let's see if we can figure it out other ways. But yeah, this has no connection whatsoever. So I think what's happening is because this has fallen away from where it's supposed to be, like there's some kind of a C-clip, or I really don't know, in here that holds this entire cylinder up in this housing. The little arm here, it looks like that. Oh, I'm doing gang signs now. It looks like this. And that rides this way with that motor that's in here, the off-centered ball bearing. And as it goes around, it goes side to side, and that's what moves the blade back and forth, so that you figure there's a C back here, and it's rotating it back and forth. And obviously it's not going to run right if that is allowed to pop outside or underneath the dimension of where this is riding, where that's riding on this. So let's see if I can't take it apart further and keep exploring. All right, so while I was away a second ago, I was out in my shop. I don't videotape out there because it's freaking hot. It's summertime. AC, I like it better than sweating. So I took the lever off because I realized just by looking at it, there's a seal here, as you can see by the raised lettering. This is obviously a closed housing, so everything was pressed in that way. And then this oil seal or grease seal around here, similar to the same thing you'd have on like a wheel hub on a tractor trailer or even your car, that's pressed in after the fact. So I got to thinking, after I removed this pin, and by the way, with the pin, you can use a hammer in a drift punch and like a little nut underneath it so that you don't bend these ears, but you're going to do a little bit of damage to it to get it out. And then once it comes out, the pin shoots off and takes 20 minutes to find, like it just took me to find. Or you can just use a hydraulic punch, or excuse me, a hydraulic press, which I happen to have one, but I did not use it because there's a project car in front of it right now. That's what I'm thinking. That's what I'm thinking. I'm thinking the issue of that is because this is supposed to be pressed into that recess. So I brought this thing back in just to share this little thought process with you. But if it doesn't work, obviously I'll be back in a second. If it does work, I'll be back in a second. Either way, you'll know whether or not that works or not. Now I'm thinking, since everything has to be pressed that way, simply the pressing failed, and that's why it's doing that. And that's why this is out of sync and out of alignment with that. And that's where we're getting the heavy vibration and the nasty noise. So I'm gonna go try that out. So I'll show you how I did it. I think it worked. I think. It's outside the parts washer right now. I pressed the tool end on that side, the lever end on that side. Here's that lever I was talking about, and that stupid pin that shot out like a freaking, like a bat out of hell. This is my arbor, I guess you can, I wouldn't call it arbor, my press surface. I went ahead and took these two little red bushings that you saw in the previous video. I took them out of it because, like I said, I had the thing in the parts washer right now. I had to use the bench vise because my hydraulic press is behind project vehicle. I'll eventually get to it. Let's go check up on the part. So I've had it sitting in my parts washer here for a few moments, mostly to get all the grease out, because I really wanted to see what's going on the inside. So as you also see, I was able to press this piece back into that piece with a piece of wood here, piece of wood there, and just use my bench vise to press that piece back in. When it was really tight up to about, I don't know, maybe 1/8 of an inch, 3/16 of an inch, and then it went snap and it shot up into there, kind of like it fully set. So I don't see any damage on the inside. This doesn't move, which does concern me a wee bit. But I don't know. We're gonna try it out. All right. An important development. When I brought it back outside to push or to hammer that thing back in using a brass hammer, that pin through the handle that I had off previously, I went ahead and engaged it, and the whole thing fell out again. And that's when I found this guy. It's a freaking snap ring. So there's a snap ring that I'd be willing now to bet is supposed to go around a bezel or a groove on this shaft. So what I have to try to figure out how to do is to get this guy off, right? And then press this portion back into where it's supposed to be. And I bet you anything right now, I tried pulling it off just like this. I wasn't able to go earlier. I went, It did go, and look what we have here. The snap ring is broken. So a literal 1/2 cent part could be the reason this, again, $100, $200, $250 tool failed, because they chose, and it was a choice. Make no mistake about it, it was a choice by some jackhole in frickin' marketing who said, yeah, well, we can use real good steel on our snap rings, or we can use these really chintzy ass ones. And the consumer, they're a bunch of idiots. They'll keep buying our crap because, after all, we are Milwaukee tool, right? So let me go see if I can't, now that the lever's in there, press that back up and see if that reveals, because I bet you it will. It's going to reveal on this cylinder down here, probably about there, but in there, a little groove where that guy fits. And if that's the case, that holds this up, because when I pressed it up earlier, I did not see the snap ring, because the snap ring, I don't have a flashlight on me, hold on. Because that snap ring, well, you can't see it on the camera at all, can you? Well, crap, there goes my explanation. You really can't see that. Anyway, take my word for it. Inside of here, there is this little wafer. This wafer gasket. You can barely see it. I'm moving it with the pick. It's like a wave washer. It just puts a little bit of tension. I bet you anything there's a groove on that. So let's take it back out to the shop. Okay, it just freed itself. But that piece, somehow or another, that piece. Let's see if we can do this in real time. I'm trying to make this video too damn long. That just means more editing, more bullshit for me, and more really poor and terrible video you have to watch. So how would I make that come out? Let me think about this. So I chucked up the part. I was able to get my garage door open. I chucked up the part and started pressing it. From about 3 seconds into it, that occurred. That's why you don't buy freaking tools from China, right? Cheap Chinesium metal. It's not even worth shit. I mean, I have nothing to say about that other than metal should not bend so easily. All right, so we're gonna try out this guy. I think it's also made in China, but it has an American brand name on it, so let's see how that fares. All right, so our diagnostic is completely over at this point. The fucking cheap-ass Milwaukee housing broke at about 15.5 tons of pressure. I guarantee it's made in China, but if not, kick ass. Stanley Fat Max punch survived the ordeal, and when it shot off of the press, it actually punctured a brand new beer that I just opened. Hold on. Okay, so now that I have beer all over me, can't drive anywhere. Don't buy this fucking tool, man. This costs what? $30 to manufacture, $25, $30 to manufacture, and apparently it's all due to a poor snap ring engagement that I don't even, again, know where it even goes, because I found the snap ring up here, and there's nothing on this piston that a snap ring could emboss upon. There's no edge on this part of the unit where I found the snap ring that a snap ring could actually spread out and create a lip. I'm not an engineer, folks. I'm a fucking mechanic. So if you want to save yourself a beer and the trouble of spending 3 freaking hours of trying to unfuck the situation, just don't buy Milwaukee crap tools. Everybody says Milwaukee's the greatest, Milwaukee's the best, Milwaukee's where it's at. Now, you know what? It's fucking garbage. It really is. Milwaukee is absolute crap tools. You're to spend good, hard-earned money on shit-ass, homeowner-grade, housewife-grade bullshit-ass tools that you cannot use on a job site. So, fuck these people, fuck their manufacturing, fuck Milwaukee. I need to take a shower and grab a new beer. So, closing thoughts. Now that I had a chance to calm down a little bit. When the press misaligned, it blew an ear completely off. And you can tell because of the way. Can I zoom this in? Holy crap, the iPhone zooms in. All right. But you can tell because of the metallurgy right here. This is not real metal. This is cast bullshit ass crap metal that I think I said before it took $30 to make this part. I now believe it took $10 to make this part. Maybe 15 because this is sintered metal. This is not machined. That part might be machined. I don't think it is though. So this is a $20 part. And that's what's going to screw you every time because of a 1/10 of 1 cent snap ring that breaks off. Thank you, fucking Milwaukee. Thank you, China, for making more junk that we're spending, again, a couple $100 on. Get bent. Make better tools, or no tradesman should ever buy these tools. None. Zero. Luckily, my buddy, the guy who said, hey, Bo, can you fix this? We didn't pay for this. Our company did. All right? But I buy my own tools. Like this flashlight. I bought this flashlight. I like this flashlight. It really works. If a person's paying for their own tools, they should get a value for that tool. A value meaning more than just 3 months of use. More than 20 hours of use. Milwaukee, I've said it before in my last video, you are better than this. You're better than this. Stop futzing around and make better tools. And I guarantee you, if you make it, tradesmen will come. Thank you for watching. I would love to have any comments you have in the comments down below about what I could have done to fix this without blowing it out with a 20-ton press. Has anybody ever taken one of these apart? Do they know how to get this cylinder out? I mean, obviously I can't fix this, but I would still love to learn if anybody out there knows how to actually take this thing apart. So, until the next one.